All right, this is a very confusing question, so please don't feel lost. We've got y equals cosec x, and we're having a look at cosec theta, sorry, and cosec is 1 over sine. Now, I'm just going to bang out a really quick diagram of sine theta. It'd be really good if you could watch what I'm doing and do it yourself when you can, because it's really good to be able to bang these out really quickly, yeah? So I'm going to go all the way to 360. So I'm going to make this 90, 180, 270, 360. Now the main landmarks of sine x that you need to know is it starts at 0, it's 1 at 90, 0 at 180, minus 1 at 270, 0 at 360. So it goes up like down and up. And that's sine theta, yeah? And this was 1 and this was minus 1. I don't really care about any of the intermediate values. Although I could draw this to actually go through the points. There we go, that's better. Now, you can see from this, the reason I chose to draw this really quickly was sine 0 equals 0. Sine 180 equals 0, sine 360 equals 0. And if we're looking at cosec theta is 1 on sine theta, yeah? So here it would be 1 on 0. Here it would be 1 on 0. Here it would be 1 on 0. So that's undefined. Remember when we had our hyperbolas and it was y equals 1 on x and it deliberately didn't hit when x was 0? That's because it was undefined. That's what we call a vertical asymptote. Vertical asymptote. Okay, so now let's look at when sine x has a maximum of 1. So what we just looked at was whenever sine theta equals 0, so that kind of addressed that. Now let's address when it has a maximum of 1. So sine 90 equals 1, which means cosec 90 is going to be 1 on 1, which is 1. Sine 180, hang on. So that's its maximum, yeah? If I have, for example, cosec 120, then that's 1 on something that's smaller than 1. So sine 120 is smaller than 1. So cosec 120 is 1 divided by something smaller than 1. If you ever have 1 divided by something that's smaller than 1, for example, let's do 1 divided by 0.86. That gives us 1.16. It's bigger than 1. So that's why we have a minimum of 1 for cosec. Because sine theta never gets bigger than 1. So 1 divided by this is never going to get smaller than 1. And it's going to be the same whenever we look at the minuses as well. So let's actually have a look at cosec. We can do a fairly average job of drawing this once again. So this is going to be 90, 180, 270, 360. I'm going to call this 1 and, actually I'm going to go smaller for my 1. 1 and minus 1. Now, we're going to have vertical asymptotes whenever sine theta is 0. So it's never going to hit here. It's never going to hit here. It's never going to hit here. When sine theta is 1, cosec theta is also going to be 1. So we're going to be here. Let me make this bigger. Yeah. We're also going to be here. But it's going to be a minimum there, so it's going to kind of go up from there. And here it's going to be 1 over minus 1, which is going to be minus 1. So it's going to kind of go down there and it's going to be negative. So if we actually had a look at that, that's what it would look like. Ugh, that sucks. Don't do B.